Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-1 for October-November 2024, questions 5 to 7. Question 5 is coming from normal distribution. The weights of the green apples sold by a shop are normally distributed with mean 90 grams and standard deviation 80 grams. Part A, find the probability that a randomly chosen green apple weighs between 83 grams and 95 grams. Okay, so we have our mean is given as 90, standard deviation is given as 80. So we are told to find the probability that a randomly chosen green apple weighs between these two. So I'll put 83 here, less than x, less than 95. Then we standardize. Remember, z is equal to x minus mu out of the standard deviation. So our x here is 83 minus the mean, which is 90, then divide by standard deviation is 8. Then less than, where there is x, I put z. Then it is going to be 95 here minus 90 again out of 80. So this one will give us probability of here negative 7 over 8, which is less than z less than this will be 5 over 8. So this is what we are having here. If I may draw the barrel-shaped curve, this is what we are going to have. So negative 7 out of 8 is on the left of this mean, which is 0 for the standardized normal distribution. And then here I can have the 5 over 8. So we want this probability in between. So that means if I'm looking for this one, I'm going to get the whole of it less than this, then minus less than this one here. Okay? So we are going to have probability of z less than the positive 5 over 8, and then subtract probability of z less than negative 7 over 8. I can put this one in the calculator straight away and I get the answer. In the previous videos, I've been telling you to always first check whether the calculator is in the statistics mode. If it is not, then you press mode, then start is number 3, then you press SC here, and then you can press shift, then 1. That is where we are seeing start 1. Now distribution is on 5, and that is for normal distribution. P is for less than. So I'll press 1 here, and then now I'll just put my 5 over 8. And that one gives me 0.73401. 0.73401. This calculator gives up to 5 decimal places, but in the table we get up to 4 decimal places. How about when we put negative 7 over 8? I'll just come here and put negative 7 because it is still for less than. Then this one gives me 0.19079. 0.19079. When we subtract the two, what do we get? 0.73401 minus 0.19079. That is 0.54322. But I'll write the 3 significant figures, and that will be 0.543. Just like that. Part B, the shop also sells red apples. 60% of the red apples sold by the shop weigh more than 80 grams. 160 red apples are chosen at random from the shop. Use a suitable approximation to find the probability that fewer than 105 of the chosen red apples weigh more than 80 grams. Now, in here, you cannot, this is a binomial because you are doing the experiment every now and then, and the P is the 60%, okay? So P is equal to 0.6, and therefore Q, the probability of the failure, is going to be 0.4. Then the N is given as 160 red apples, okay? Now, you cannot find probability of less than, of X, let's say less than 105. You are going to have probability of X is equal to 104, 103, 102, up to 0. When will you finish? Okay, so that is why we approximate the binomial to the normal. And then, of course, to use the normal, you need to get the mean. So mean is given by NP. So n is 160 times the p, 0.6, and this one gives us 96. Then we need to get the standard deviation, which is root of variance, and variance is npq. These formulae are given in the list of formulae that they give you. So this is 160 times the p, which is 0.6, times the q, which is 0.4. Okay? Then what does this one give us without the square root? 160 times 0.6 times 0.4. That is 38.4. 38.4 under the square root. Okay? Now, before approximation, we do continuity correction because we are moving from discrete data and we are going to continuous data. Normal distribution deals with continuous data. Now, I have the number here. Okay? The number is 105. Then here there is 104, and then here there is 105.5. No, 105. Okay. Now in the middle here there is 105, 105.5, and also here there is 104.5. These are the boundaries of this number 105, where this is the lower bound and this is the upper bound. Okay. Now when we round off all of these figures here, they will give us 105. Okay. But then when we round off this 105, it is going to give us 106. Actually, here we have, let me put this one, it is 106. Okay, so this one will go to 106 when I round it off to the nearest whole number. Okay, that's why we write like 105 is less than 105.5 and then less than or equal to 104.5. So meaning that all of these ones here will give us the 105 when we round them off. But on this 105.5 when we round off, it is not 105 anymore. It gives you 106. So that's why this one is less than. Okay. You used to do this in IGCSE. Okay. Now, leaving that aside, we are now going to have probability of x less than 105. So which is going to now be, when I round off the figures, what I get must be less than 105. Okay, so it has to be below this one here. All of these figures that you get here will not give you 105 when you round them off. They will give you a figure which is less than the 105. Okay, it starts to be 105 from here, the 104.5. Okay, so that means we are going to have something like this, that this one will now approximate to 104.5. Okay, all figures that are less than this one will give us the rounded figures as less than 105. Okay, and then we can standardize here. It is probability of z, okay, less than, remember our z is given by x minus mu out of the standard deviation. So I'll have here the x 104 minus the mean we have calculated as 96 out of the standard deviation, which is square root of 38.4. Okay, so I can put this in the calculator straight away and I get the answer. Okay, I can have probability of z less than 104 minus 96, it will give us 8.5. This one, I can leave it here, 38.4. Okay, and then I can use the calculator straight away and we get our answer. So already our start is still there. So I just press shift, then 1. Then distribution is 5. And then this is less than, so I'll go to P, which is option 1. And then I will put the 8.5, then divide by the square root of 38.4. Then we get 0.91492, but 3 significant figures, we shall have 0.915. 0.915 to 3 significant figures. Okay. Alternatively, you can use the table. Okay. You can use the table. So what do we have here using the table? It is going to be probability of Z less than, this one has to be to 3 decimal places, okay? I'll get 8.5 divided by the square root of 38.4. This one gives me 1.371. So 1.371. It has to be to 3 decimal places. Now you can go to the table. So this is the normal distribution table they give you on that booklet for the list of family. Now we have 1.371. So 1.3, then 7 is here. So I'll pick this one here. And then there is a 1 here. So come down here. And then pick out these 2. That means it is going to be 0.9147. Then this value that is here, I will add it from this side, 0, 0, 0. So when you add, you get here 49190. So when we round off to 3 significant figures, it will still give you 0.915. Okay? So that is that. Question 6. The heights of the female students at Brevin College are normally distributed. 90% of the female students have heights less than 182.7 centimeters, and then 40% of the female students have heights less than 162.5 centimeters. And then they are telling us to find the mean and standard deviation of the heights of the female students at Brevin College. So we are going to have probability of x less than 182.7, and it is given as 0.9. That means we are going to standardize this and we say probability of z less than, there is a z1 that corresponds to this, okay, which is equal to 0.9. So we are supposed to locate this value here. I can begin by sketching this normal distribution curve, this bell-shaped curve, but we need to know whether z, first of all, z is supposed to be the phi inverse of this 0.9, okay? We need to know whether z is positive or negative. So I can first put this z1, maybe here, it is a negative, and then on the right of the mean, which is 0, okay, that is z is this other side, so less than. When we put less than, that means we are looking at this side or this other side here. And then you ask yourself, which of these two, the negative or the positive, the shaded regions that you are seeing, which of them is giving me a value that corresponds to this 0.9? It has to be the second one here, okay? Because you can see this one is very small. First of all, in probabilities, in normal distribution, this one is equivalent to 0.5. Even this other side is 0.5. So meaning this one has to be less than the 0.5, you see? So that means our z is going to be positive. Now we go to the normal distribution table and we look out for the z value that corresponds to the probability, which is 0.9. Now when you come to the normal distribution here, for 0.9, I'm supposed to look out for it from this table here, okay? Then I trace the z values where it is coming from. But before you do that, first go down here, there is this table that is given always down here for the critical values. So I look for 0.9 and 0.9 is already there. That means the z value that corresponds to it is 1.282. 1.282, okay? Remember, z is equal to x minus mu out of the standard deviation. So meaning we shall have 1.282, which is equal to, our x is 1.82, no. It's 182.7 minus the mean, which is given, which is the one we are looking for, okay? Then the standard deviation. Now when we cross multiply, we can have 1.282 times the standard deviation is equal to 1.8. I don't know why I'm writing 1.8. 182.7, then minus the mu. So meaning if I can make this mu the subject of the formula, okay, or I can just leave it there, okay, that is equation 1. Then I can go to the next one. They gave us 40% of the female students have heights less than 162.5. Okay, so I will write probability of x less than 162.5, this one is equal to 0.4. So meaning when we standardize this probability of z less than, let's say z2, we need to find the z value that corresponds to this 0.4 as a probability. Now, we also do the same. We do a sketch here and also here. Okay? Now, we can put the z2 here, which is a negative, or it can be this side, it's a positive. So we are looking at less than. Okay? So less than is this one here and also this one here. Then you ask yourself, which of these two regions do you think corresponds to the 0 point? Okay? Which of them corresponds to this 0.4? Automatically, it has to be this one here. Why? Because this one is bigger than 0.5, because just this one here is the 0.5, you see? So there's something that is added on it. So it will be bigger than 0.5. So we are picking this one. So meaning z is a negative value, and then we find the phi inverse of the 0.4. But in our table, we don't have values for the probabilities that are less than 0.5. The smallest is 0.5. Okay, so meaning since these z values are just boundaries, okay, we can instead get the value of the probability which is greater than 0.5. In other words, we just subtract 1. If this is 0.4, then this one will be 0.6. Okay, so we instead look out for that 0.6. So phi inverse of 0.6. Now we go to our table and then we find it out. So this is our table here. Now we go and look out for 0.6. So 0.6, if you can look at this one here, this one is 0.5987. Okay, so 0.6 is around here. You see that? So I'm going to pick out this value, 0.2, and then this one here, 5. So I'll write 0.25. Okay, now there is something that we must add on here, okay, onto this probability so that we get a 0.6. Okay, so we can get 0.6000. Then we subtract 0.5987. I think this one is going to give us 13. 100 minus 87, you get 13. Okay, now you go this side and you look out for 13. There is no 13, but there is 12 here, which is nearer to it. So that means I will pick out this value here, the 3, which is the third digit in the decimal places. Okay, so our z is going to be 0.253. So I can now go back. So z2 is equal to negative 0.253. Now again, so we shall write negative 0.253, which is equal to your x, and the x here is 162.5. Then we shall subtract the mean, which we are looking for. Then we divide by the standard deviation. Okay, now from here I can cross multiply, and then we have negative 0.253, the standard deviation, then is equal to 1.6. It is 162.5 minus the mean. So that is the second equation. Now we can solve these two simultaneously. Okay, solving 1 and 2 simultaneously. So what do we get? We can actually just subtract them such that that mean disappears. 182.7 minus mu, and then this is 160, no, it's a negative 0.253 sigma, then is equal to 162.5 minus mu. So when I subtract here, our mean here is going to disappear. Okay, then here we are having 1.282, then minus, so it will be a plus 0.253, okay, of sigma. Then this one is going to be equal to 182 minus 182.7 minus 162.5. This one will give us 20. Because 182 minus 162, that is 20. Now 0.7 minus 0.5, so it will be a 0.2 here. So meaning the standard deviation is going to be equal to 20.2 out of, when you add these ones, they give you 1.535. Okay, so now what is the value of standard deviation to three significant figures when we put in the calculator? 20.2, then we divide by 1.535. That is 13.2 to three significant figures. 13.2, three significant figures. Then next, what is now the value of mean? So I can bring mean here and then I take it there. I have two simultaneous equations, so I can use any of them. So mean is going to be 162.5. Then we shall add the 0.253 of this one. Remember, this one went here, then this one came this side, okay? Now, we are going to have this one here times. I'm not going to use this rounded figure, okay? I'm going to use this exact fraction here. So we shall have 20.2 here out of 1.535. So altogether to three significant figures, what will be the mean? 162.5 plus 0.253 times 20.2, then we can divide by 1.535, and then altogether we get 165.8, and all of those figures can write it as 165.8, or I can write it as 166 to three significant figures. 10 female students are chosen at random from those at Brevin College. Part B, find the probability that fewer than 8 of these 10 students have heights more than 162.5. Now, this is a binomial, okay? It's a binomial because the n is known and the outcomes are all independent of each other. So, probability of x less than 162.5, okay? This one, they said that the students have heights more than that, but we have for less than, and it was given as 40%. So meaning that probability of x greater than 162.5 is going to be equal to 60%. You see that? So our p in this case is therefore going to be the 0.6. Okay? P is going to be 0.6. Q will be 0.4. Then our n is 10. So since n is fixed, this is a binomial, like I said. So probability of, let me say, y less than 8, okay? Less than 8 out of the 10. So this one is going to be equal to, you will consider 7, 6, 5, 4, 3, 2, 1, and 0. But then, that is hectic. Instead of doing all of that, why don't I say 1 minus probability of x greater or equal to 8? Because 8 here is not inclusive, that means here I can include it. So meaning we shall have 1 minus probability of x is equal to 8, then plus the probability of x is equal to 9, then plus the probability of x which is equal to 10. Okay, like that. Now, that means here we are going to have 1 minus. Now this will be 10, then combination 8. Then our p is 0.6, which is appearing 8 times. And then our q is 0.4, which is appearing 2 times. Remember, when you add these two powers, you get the n here, which is 10. Okay? Now, after that, we are going to add on 10 combination 9, then 0.6 power 9, 0.4 power 1. Then 10 combination 10, which is even 1, then times 0.6 power 10, and then we shall multiply this one with 0.4, then power 0, and it is also 1. So putting all of this in the calculator, what do we get? So I'll put 10 combination 8, then times 0.6 power 8, and then after times 0.4 squared. Close the brackets. Then I go to the next one. 10 combination 9, that will be 10, then times 0.6 power 9, then times 0.4. Then close the brackets. And then I go to the next one, which is 10 combination 10, which is 1, then 0.6 power 10, because the other one is also 1. So altogether, I'm having 0.16 and the rest of those figures, okay? But then I'm supposed to subtract this one from 1, okay? So I would just say 1 minus the answer. So it will give me 0.833 to 3 significant figures. 0.833 to 3 significant figures. Like that. Question 7 is coming from combinatorics. That's what we call permutations and combinations. Part A. How many different arrangements are there of the 9 letters in the word intellect in which the 2 T's are together? So I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 2 T's are together. I take this as one group, okay? As if it is one letter. So that means I have 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I will have 8 factorial here. 8 factorial. Then out of, do we have the repeating letters? We have, other than the T's, we have E's. There are 2 of them. So I'll put 2 factorial. And then we also have L's. We have 2 L's here. So I'll also put 2 factorial. I would have multiplied this one by 2 factorial because there are 2 T's, but I'm going to divide by 2 factorial because they are in a line and they are repeating. You see? So there is no need of writing this one here. It is optional. So that means our answer here is going to give us 8 factorial. Then I will divide by 2 factorial is 2. So 2 times 2, that's a 4. Then 10080. 10080. And then part B, how many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and the 2 E's are not next to each other? Okay. Now I'm going to pick from my sample space where the T's are at each end. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a T is here. I cancel that position. A T is here. I also cancel that position. Okay. So T's at each end. T's at each end and no other restriction. Now, in here, remember they are 9, so minus 2, I will get 7 factorial. Now, the T's are killed, but then we have 2 L's in here, and we also have 2 E's in there. So, that means we are going to have here 2 factorial, and then also 2 factorial. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can still have the 2 T's at the end, okay? So T's at each end and 2 E's together, okay? So they are saying when the 2 E's are not together. So I can find when they are together, then after I just subtract, because when we are arranging them in here, they can be separate, okay? Or they can be together. You see that? So when the 2 E's are together, that one is going to give me one group. You see that? One group. So I will have 1, then 2, 3, 4, 5, 6. Okay, so that will give me 6 factorial. So it will be 6 factorial, but now there are two L's in there which are remaining. So 2 factorial. You see that? Then I'm not going to multiply by 2 factorial over 2 factorial for these e's. There are two e's. I can arrange them in 2 factorial ways, but then they are in a line and they are repeating. So I divide by this, the sum to the t's, like I showed you before. Okay? This one is all optional. So you don't waste your time if you are having identical letters which are put together. However, if these two were different, then I would multiply by that 2 factorial here. I guess that is clear. Now, that means if we have t's at each end, okay, and the two e's are not together, so the number of those different arrangements is going to be 7 factorial out of 2 factorial times 2 factorial, because this is now the sample space we are picking from. Okay, then minus 6 factorial over 2 factorial. Then what does this give us? 7 factorial, then divide by 2 factorial times 2 factorial, that is a 4. Okay, then minus, we have here 6 factorial, then out of 2 factorial is a 2. So we get our answer as 900. 900. Just like that. Then lastly, 4 letters are selected at random from the 9 letters in the word intellect. Part C, find the percentage of the possible selections which contain at least one E and exactly one T. Now, they said possible selections. They didn't say different selections. So, we are going to consider these repeating letters as if they are different. Okay? Scenarios. So I can have the E's are 2, and then the T's are 2. Then others, here, there are 5 of them. So we have 1, I can have a 1 here, and then 1 here. Remember they said at least means greater or equal, okay? Then I can have 2 here, then 1 here. You see? Of course, if these are 5, and I have already 2 here, that means here I will have 2. Because we are selecting 4, okay? And then here we shall have 1. So meaning I'll have 2 combination 1. Out of the 2, I'm choosing 1, okay? Then times 2 combination 1, then times 5 combination 2. And then down here, I'll have 2 combination 2 times 2 combination 1 times 5 combination 1, okay? 2 times 2, 4. Then 4 times, this one will give us 10. That one will be now 40. And then here, 5 times 2, that is 10. Then 2 combination 2 is, of course, 1. So we shall have 10. Now, our probability is equal to these possible selections. We have gotten 40 plus 10. Then out of the 9 letters, without any restriction, we are choosing only 4, okay? So putting this in the calculator altogether, what do we get? 50 divided by 9 combination 4. And the answer is 25 over 63, okay? 25 over 63. 25 over 63. But they asked for the percentage. So therefore, the percentage is going to be this probability I've gotten, then times 100. And to 3 significant figures, what do we get? I will just come back to this times 100. That is 39.7. 39.7. This is to 3 significant what? Figures. So, I repeat something small here. Here they said possible selections. They didn't say different selections. If they said different selections, that means we would consider the picking from others. Even here we would have included L's because L's are repeating. They are also 2, okay? But we are just looking at this as if they are different. Like all the letters are different because they said possible selections. So that means if there are two ways you can pick an E from that lot because there are two E's. So that's why we are considering their combinations. Okay. But if they had said different selections, we are not picking anything from here. We are not using these combinations here. So we just pick from the others. Okay. So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.